Welcome to the webinar. I'm Cheri Guntzviller, and I'll be your presenter today. We're going to start with the second session here from the previous hydraulic and pneumatic, as well as P&ID topic. And our title today is Following the Flow of P&ID in SOLIDWORKS Electrical. We will be looking at some more complex circuits, specifically with some cylinders. And those cylinders are going to be connected to valves with plastic tubing. And we will take those and route them inside a framed assembly. But we need to identify a couple of different areas on whether you're using SolidWorks routing or SolidWorks Electrical and the automatic routing. During this webinar, we'll look at some tricks to make routing even easier. We'll look at some routing parameters that are key in 3D electrical. And then also we'll be using some macros to speed up the design within our schematic. Before I begin, I want to give you just a little story. As I worked my way up through the ranks, one of the experiences was working side by side with a wonderful man named Boris. I grew up learning to draft on a board with a T-square and a pencil. I found that this relic last weekend and thought you might find this amusing. Here's a template that was used for keeping all the symbols the same. You can still buy some of these, in fact, in some stores, and you can find them online as well. Mechanical pencils hadn't even been in existence yet. Making sure that your pencil was sharp to draw through the template was critical. We had a piece of sandpaper next to the board continuously. We even had a sock that had that would capture the graphic dust off the drawing so that smudges were kept to a minimum. This might bring a smile, memory, or even a horror story for some, and a laugh or shock or maybe amusement to others. Talking about symbols, if you watch the previous webinar to this one, I did want to clarify one area. If you downloaded the symbols from the electrical content portal for the P&ID symbols, you may have noticed that they didn't all fall into the classification of process and instrumentation. They are located under a new library that was added to your software, and it's a pneumatic hydraulic ISO 1219-1. And you can see that here on the screen. Selecting the radio button, any class will then provide that entire library that was downloaded. Okay, let's move on. I'm going to build a more complex pneumatics schematic. So let's look at a schematic that we've already developed. I'm going to look at the cylinder. Now, this cylinder has lots of information baked into it through the component properties, including the fact that it has a manufacturer's part. This manufacturer's part is a Bimba cylinder. It has some information here on the properties pane, including a 3D model that has been assigned to it. Now, this model could be in your vault or on a server somewhere. Let's look at this cylinder symbol. So we'll go ahead and open up the symbol here. And I can assign a manufacturer directly to this symbol. Now, Bimba is not in the list, but just like anytime you're searching for a part, if you know the part number, go ahead and put that in instead. So it might be due to classifications or types or something like that. Go ahead and type in cylinder, or for me, I'm typing in cylinder, and I can remove the classes and simply find the Bimba cylinder to assign it to this symbol. Whenever I use this symbol, then that Bimba cylinder is going to automatically be assigned to the component. So I'll go ahead and save it. And now I'll go ahead and use it in a schematic. So I've got a schematic here that's already open or already created. I'll go ahead and find my cylinder symbol. And now I'll just place it on the page. So it comes up with the numbering, but I'm going to add some additional information to it. So this is all the information for ports and bore size. And then I'm also going to give it a description. Now I've built the symbol to actually utilize that user data field. And I have broken it up using a multiple attribute so that you can actually see all that information. And the component, if you look here, you can see that the component actually has that Bimba cylinder already assigned. I can remove it and replace it with something else, but as a default, it will then bring in that part. Let's go ahead and open up the assembly now, and I will use that assigned 3D model. So we already know that it is 1009C. That is that part. So I can find that in the browser list here under the electrical, and I can simply say insert, and because it knows the 3D model, it will then place that. So we'll go ahead and open up the 3D model for this symbol. There are some features that have been added to it to make it an electrical part. Now you'll notice that there are some new features like this 00 and the 01. There's also a sketch. And you'll also notice the sketch for the point as well as this EW path. If I look at this device through the component properties, I'm going into that manufacturer. In the circuits and terminals of this device, you'll see that we have a hydraulic and pneumatic circuit 0. Down in the lower section, you have two terminals, one for inlet, one for return. Inlet is 00. The return is 01. So on this 3D model, that is what it is referring to when you see the feature of 00 and 01 is the inlet and outlet points. On top of that, you also see a path or a 3D sketch. This 3D sketch has been converted utilizing the electrical tool. So you can find the electrical tool here under Tools, under SOLIDWORKS Electrical, and define routing path. Now you can use this function to actually create a sketch or to convert a sketch. It must be a 3D sketch. So once it has been converted, it will then turn it the color of yellow and rename it to this EW path. This path is where the tubing or wires will then follow utilizing electric. You always want to save the part afterwards. In this case, we didn't make any changes, so we won't. So let's look at another device. We're going to look at now an FRL unit, so a filter, regulator, lubricator. We'll find a symbol to begin with. So I'll just search for my FRL unit. And I have built this symbol to actually hold all three devices, so it becomes just one kit. Placing this comes up with the fact of wanting just a standard number. I'm going to give it an FRL name. But the one thing that I am going to look at is I see that this is coming up as manual marks. I don't necessarily want manual marks, so I wanted to make it automatic. But this device has no component to it. If I go to 3D and look at my subassembly here for this location, you can see that there is no way if I right-click to even insert. So I have to assign a manufacturer's part to this. I can either do it here in Properties, or I can go back to Schematic and do it there. Here, I'm going to do it in Properties in this 3D. Notice it has two hydraulic circuits. Well, if I want to create a manufacturer, it's going to grab that information from that symbol and put it into this manufacturer, so I don't have to play around with all of that. I'm going to go ahead and just make a generic FRL part that I'm going to add to the library here. And now it's available for anyone to use. By simply saying OK, it is now available in 3D where I can expand it and say Insert from File. Insert from File will allow me to browse to a device in 3D to then place in my assembly. So I'll place it here in this environment. And then I'm going to open up the part to take a deeper look at how this part is made. Now this part, as we look on the inlet side, has a threaded connection. So this is going to be more of a rigid pipe route. Therefore, it's going to be handled through SOLIDWORKS Premium so that I can add the connector as well as the rigid tubing. The lubricator do have hose connections, but here being that it's just a single hose connection, I'm probably going to route these individually as well so I have full control of where they are at. I'm not going to go into that during this webinar because truly I want to just focus on the tubing for the valves to the cylinders. So let's take a look here at the schematic. So the first symbol here is just some simple text that I've added. The tube or the pipe coming into the FRL unit, we already know is hard pipe. And then, of course, we have probably some rigid tubing that's going to this muffler. The muffler itself, that symbol, is a passive, it's not a passive symbol, it is a schematic symbol, but it has no circuitry. So I'm not needing to necessarily worry about a connection, but yet it can still hold a manufacturer's part for the BOM. Now this next symbol here, I kind of like the layout. The symbol itself, I might need to do some modification, which I'll show you how to do that. But really, I want to focus just on this graphics that is in the symbol at this point. This graphic is just showing a three-position valve, but we can put in any graphics at this point. So you could take this symbol and make a multitude of symbols just by swapping out the graphics. So moving on, then of course we've got the plastic tubing that goes into the cylinder. This plastic tubing is just a wire style. So this wire style, we've called it, it's in a group of pneumatic tubing. And notice that there are two sections here. One is for cabling, that is for 3D. That's where it's going to get that diameter and also the bend radius. I've got two regulators here. Normally, if you're doing most types of pneumatics, you would be adding those regulators into the line, but for ours, really those regulators are built into either the valve or they're built into the cylinder. So I'm going to leave those out for the time being, but they are there just in case I decide I want to place them into the 3D model for any reason, or the 3D assembly. Now, to speed up a design, I'm going to use a macro. So I'm going to copy part of this circuit because I know that I'm going to use this circuit over and over again. To do that, you simply highlight it, and I'm going to copy with an insertion point. Now my insertion point is going to be the beginning of that circuit, and I am going to then place it as a new macro into this browser, which basically puts it into a library. That library is then available for all users immediately. But now your circuits can actually look the same without you having to redesign it. At the same time, that circuit is gaining all of that information that you've already built in, and it then becomes something that is always available for the users so that you're not having to redesign. Now, if you want to do any changes to this, when you place this macro into a schematic, It has no idea that it was a macro. You will be able to edit it on the fly, on the spot, making changes as you require, which will not affect the macro in the library, and at the same time will not translate to any other projects. It will be as if you designed this circuit on the spot. So we're going to go ahead and make a macro also here of the solenoid valve and cylinder. And then lastly, of course, I've got this closing muffler. Now, we'll just go ahead and I'll use those macros now. So I'm just going to clean up this sheet and start by just dragging and dropping. So that's all you were doing. And then there is this option for a paste special. That paste special then gives you the ability to use either existing marks or to change the marks for each of these devices. And then I can just drag in also the circuit that had the cylinder as well as the solenoid and valve. So I'll do this just a couple more times. Because of the insertion point, it's easy to figure out where to position each of these devices. At the same time, notice that as I'm dragging them in, the component tree, then those marks are getting updated automatically based off of the page I'm on and the instance, because that's how the project template is set up. So we'll go ahead and then add that muffler at the end. So we'll finish up this circuit now. This is our P&ID circuit. So here we have P&ID pretty much set up with all of our different componentry. I'm going to go ahead now and look into this symbol a little bit further. I'm going to start by going into the component properties. And here I'm going to add a description for cup number 4 and make it a more of a control for this device. And then I'm going to also add some user data. So I want to be able to call out the insertion or the insert, sorry. I want to call out the extract and retract or expand and retract of the cylinder. And maybe I'm going to also add this pipe symbol, which is a line feed, to call out the output that it is going to be using. Now that I have that information into the component, I'm going to show it more accurately on the symbol. So I'm going to do that modification of the schematic symbol at this point. I don't necessarily need all of these attributes that are currently in this symbol, so I'm going to get rid of them. And instead, I'm going to find a new attribute, and that attribute is going to be my user data from the component. There's a number of different user datas in those attributes, so be careful when you go to add the user data that you're grabbing it from the right area, whether it be from the manufacturer or from the component. I can also do things like simple copy of properties of a specific attribute, and then I can apply those. That just speeds up that process so you're not having to remember those settings. And then I'm going to use this multiple attribute. So that multiple attribute is then going to allow for that line feed. I can simply select how many of these multiple attributes I want, and I can then utilize them. Here, I'm going to go ahead and delete the secondary. Now, here's one thing that's really nice is being able to take these attributes that I've already set up, and because I'm using user data 1 and user data 2, I can then just go ahead and take both of these attributes and modify the data index point. So instead of being data 0, it can be data 1. Now, of course, the software uses 0 and 1 numbering when the text is calling out 1 and 2. You'll see that when you're working there. But I'm going to go ahead and simply save this symbol. And then I can go ahead now on my schematic sheet and update the symbol. This way I can also have legacy symbols. I'm going to go ahead and just say for the current drawing, and for anyone that I have this set up, notice I am now seeing that extend and retract. Now I'm noticing as I follow the tubing through that I'm calling out retract on one side, but it happens to be the inlet. Well, that's not quite exactly correct. It's supposed to be extend on this side for user data 1 and retract for user data 2. So I'm just going to swap out that information real quick. And when I do now, of course, since the symbol is already updated, that data is just being translated into the symbol. And so if I click off the symbol here, I can then see that additional information that has been utilized. So you can see that up at the top now. So our P&ID looks pretty good there. Well, let's go ahead and look at another sheet. So I've got another design here, which is tying the electrical solenoids with those valves. Now, this is an existing circuit, so I want to do something like I had just mentioned. I am going to copy this schematic, but I'm going to go ahead and also do another representation. So this is the representation. That's a layout. Now I could do this on a simple BOM, but I am wanting to have this on any schematic page. So I have made these into schematic symbols. And so I'm going to go ahead right now, and I've just copied the manifold only. So I'm just going to place that here. It's going to be a new device on page 11. And then, of course, I now need to look at the components that I'm going to be adding to that manifold. So those are those solenoids that I have just made on page 10. And when I right click on this device, I can say insert symbol, and I can find those other schematic symbols that are representing this device that aren't necessarily holding any circuitry, but yet now it looks like a layout of that valve. So finding that here in my library and then selecting it, I can place it. Now, one thing that's nice is I also have those center circles for where the screws would be. By using my drawing parameters here on this page, I can use the object snap, the O snap, and turning off snap, I can take those center screw holes and align them. And I can do that for all 4 of these devices. And the information that is also translated from the component also will show up here on these symbols. And this is pretty much just a layout of that manifold. All right, that looks pretty good. So now let's go ahead and remember we were talking about the solenoids. Let's just go ahead for these double solenoids, and I'm going to make this into a macro as well. Don't ever have to redesign it. I can reuse it here on this project as well as any other project. Grab an insertion point. I'm going to go into my catalog here and just right click and paste a new macro. Give it the macro a name. I think I'm going to use this page here because I want to put the electrical and the pneumatic schematics all on one page. So I placed it, but now you can see that I've got the symbols are almost overlapping. So I can simply drag to reposition my PLC cart, and then I can just drag the entire circuit over to the left. Just remember, this is as if I had designed on the spot, so this is just saving time. Now I'm noticing, of course, I need to make sure that the valve that I am calling out on top is the electrical solenoid. So on the right-hand side, I am calling out an association between these 2 devices. I'm not making anything new. I am simply associating from the right-hand side, and I'm using symbol properties. So when I right-click, going to symbol properties, I can reassign that symbol to be associated to the device that I have already designed on the pneumatic P&ID. Now that those are set up, I'm going to take this entire circuit and change the location so that I can use a new location for creating the link for the SOLIDWORKS assembly that I'm going to be making. By putting it into a new location, I'll be able to make a separate subassembly. It'll still be part of the top assembly of the project, but it will have only these components in it. So now I can draw a location outline to change all of these pieces. And when I do, it actually will even create a nice outline border showing that those pieces are on location 2. And you can see that in the browser. The component browser on the left shows all of those devices. To make a SOLIDWORKS link, I can go to Process and then SOLIDWORKS Assembly and just check the box for the link that I want to make. When I look at my documents browser has a new page. And if I look, I can see a file name for the new SOLIDWORKS assembly. Over here in 3D and SOLIDWORKS, I'm going to open up my schematic project then and be able to go to that new link of page 12. And when I do in SOLIDWORKS, what it then does is open up an assembly. Now that assembly on my feature tree will call out that same name that I had on the link from my schematic process. And then at the same time now in my browser, I have all those devices. I can still do things like regular SOLIDWORKS, like inserting existing components or parts or assemblies. Here I am using a frame that I had to learn how to build in Weldment, but now I have added slots. And remember, you can add a path inside of any part or assembly, which I have done for this frame. I have added an EW path for the tubing to follow. It can also be for the wires or sensors or anything else. Right click to start inserting, as we saw earlier in the webinar, to be able to just place specific devices. So once you have them placed, what you will then end up doing is rotating and mating these parts together. So we will start matching up paths to have them be easily able to jump from one path to another for the tubing as it is routed. So using these mates here, we will reposition for how they are going to be working if we are to add a vacuum cup to the bottom. So of course we want to make sure that these types of things, you guys are familiar with how to work with SOLIDWORKS. I don't need to explain the SOLIDWORKS side of it. But really what I want to look at is just the fact that now we can get rid of some sketches so that you can see this a little bit more clean. And we are going to have some tubes that are going to follow those sketches to connect up to the cylinders. But we also need to add the valves. So we'll go ahead and insert a valve with its solenoid. Again, you can't just right click and say insert because we didn't assign a 3D model to that valve. As long as I've got a manufacturer, I can then say right click and insert from file, browse to the file, and then place that. So here I'm going to do a little bit of manipulation and add some secondary, or add the second part, add the third part, add the fourth part once I have repositioned. But inside of these modules, I have also added a EW path. So skipping ahead, now that I have all of these modules, we are going to add some reference geometry because, of course, we need to add a 3D sketch from the valves to our framework in order for those tubes to follow. So we'll go ahead and make a reference plane, and then we will put a sketch on a 3D plane. I like using these 3D plane sketches because then it becomes very easy to adjust or modify if it is required for repositioning, moving up and down without blowing up your sketch. And of course, now I can modify that sketch through the define routing path of the SOLIDWORKS Electrical to make that into an EW path. The last step, of course, is connecting these two sketches or the two EW paths, one from the framework and one from the manifolds, for that tubing to follow, and then convert that as well. Now, as I'm looking here, I'm noticing that my path here on this reference plane is a little bit low for what I need for the tubing and for the bends coming out of those ports. So that being the case, I am going to need to modify that position of that reference plane in order to have those tubing paths to actually follow a little bit more accurately. I'll move that reference plane up a few millimeters. That looks a little bit better. I'll go ahead and save my entire assembly with my sketch modifications. Okay, and now we're ready to actually route. So under these SOLIDWORKS Electrical 3D, there is a route wires. Now, route wires really doesn't mean just wires. It is wire styles. So here we are just going to select what we are wanting to route. And I am going to select just these cylinders to route, and then it will, of course, route to the valves. And hit the green check. Now, I'm using the default parameters right now for this route. So when I do, depending on what those parameters were, they could be a little bit further out than what I'd like. If I turn off the sketch, I can see the render a little bit more clean. And now I notice this actually routed with all of the tubes, but I'm not real happy with the slot position. It came up close, but my routing parameters were not really close enough for what I needed. So I'm going to have to get back in and make a new modification to just those values for routing. To do this, we'll go ahead and turn on the sketches so that we can evaluate just where our route failed to follow that sketch. And I can see here there is definitely a disconnect with the two paths, and those tubes did not follow that. So let's use the evaluate tool to measure the distance from the 2 points of the two paths that are causing the issue, so that we can have our parameters follow more closely. I see it's at 42 millimeters, so we need to at least have that distance of 42 millimeters accommodated. Let's look at the opposite side where our valves are at. It looks like these paths don't have much of a disconnect there, so I'm not as concerned in that area. So in order to do this, all we have to do is start by going back to our electrical 3D. We simply say route wires again, and we change these parameters. So that first parameter, we're going to move that down to maybe 45 millimeters to get it closer to the actual path. And then this first point to the path is up at 120. We'll move it down to 20 millimeters and test that out. So I just need to reselect my cylinders in order to then start this process again. Simply hit the green check and let that process run for all of these tubes. Now these are a lot faster than using SOLIDWORKS Premium because we can actually route all the wires at one time. Now I'm noticing it did not route. Okay, so that means I need to adjust my parameters again. So let's make it 40 millimeters and change that, select the 4 cylinders one more time. But with SOLIDWORKS Premium, you are literally running from point to point, and then you're having to adjust each one to go through those slots and follow whatever you are wanting, but you're pushing and pulling and editing each route individually. Here, all we do is we simply push the button with those parameters. It follows that path and does all of them at one time. Now, turning off the sketches and looking at our rendered 3D assembly, I can see all of these tubes hit the slot. It looks awesome. And there wasn't a whole lot of effort that I really had to do. I created a sketch. I added some parts and mated them. I had a tube with some parameters from Schematic, and that's all it took. So let's review. At the beginning of this webinar, I mentioned that I would be showing you some tricks for routing to make it easier. I'd show you some information about the routing parameters because they are key, and then also utilizing macros to speed up the design of the process. The tricks had to do with adding a path to the part or an assembly so that the tubing could actually follow that defined route. I also was talking about how searching for a part, it's easier to type in the part number if you know that, to make speeding that function up, and then adding a manufacturer's part to a symbol to use that as a default, and also adding a 3D model to the manufacturer's part, which will also help to save time when you go to build up your assembly. Routing parameters, sometimes you need to use the measuring of those paths, the differences from point to point, to help with your route. Sometimes it doesn't want to route if those parameters are too large or too small. Also, adjusting those parameters too closely can sometimes cause that route not to happen. So you might need some adjustment. Lastly, with the macros, those macros will help to speed up the design. They are also a libraried component or circuit or pages, and macros can help create a standard set of circuits for others to use so that they always look the same and you're never having to to regenerate them. So hopefully some of these tips and tricks will make your life easier